Good morning, everyone, and welcome to this week's science video. Last week, we began a discussion about energy, and we talked about 5 different kinds of energy. Today, we're going to focus our attention on only 2 of them, and we're going to learn how those different types of energy are able to move around our world. The first type of energy that we're going to review today is electrical energy. We should remember that electrical energy is energy produced by electric charges. We know that most of the appliances, the lamps, the other lights, our computers, our phones are all they all work because of electrical energy. Without it, most of the things that we use would not exist. The second type of energy we're going to review is thermal energy. Again, we should remember that thermal energy is energy that makes us feel warm. It's the energy of heat. Also, keep in mind that we saw last week that thermal energy can also be taken away. For example, when you put water into the freezer, and that heat energy is taken away and it turns into ice. Now you may be thinking, how exactly do these different types of energy move? Well, in order for them to move, we need a very specific object called a conductor. A conductor is a material that allows heat or electric current to flow through it very easily. To understand how both heat and electricity move, those heat energy and electric energy move, we must understand that all matter is made up of tiny bits of particles. These particles are always moving. Heat is the energy of these particles when they move. If the particles in an object move faster, then the object becomes hotter. Think about a pot of water on the stove. The particles of water closest to the stove burner begin to move faster and faster. These faster particles bump into slower particles nearby and cause them to also speed up. And this in turn makes the heat spread throughout all of the water in the pot. Solids generally conduct heat better than liquids or gases. This is because the particles in solids are closer together. Let's think about if you have a conversation with your friends. Of course, it's going to be easier to hear them when you're closer together, isn't it? Particles can communicate with each other too. If they're closer together, it's going to happen a lot more easily. Now, what sort of materials make a good conductor? The best conductors are made from metals. Silver, copper, gold, aluminum, and iron are some of the best conductors of heat. However, silver and gold are very expensive, and so this is why most pots and pans are made out of copper, aluminum, and iron. You should check out the pots and pans in your kitchen and see what material it looks like they're made of. Metals are also good conductors of electricity. Lamps, toasters, TVs, and other electrical devices are connected to the wall through electric cords. Inside these electric cords are metal wires that are usually made of copper. When you plug the cord into the wall socket, these wires are then connected with more wires inside the wall, which then connect to the electric power lines outside. The electric power lines then lead to power plants that might be up to hundreds of miles away. Electricity is conducted from the power plant to the lamp in your house in less than a second. But what if you don't want the electric energy or the thermal energy to move. What could you do? You might use a material called an insulator. An insulator is a material that prevents heat or an electric current from flowing. Electrical insulators prevent the movement of electric energy, of course. We just heard about electric cords and wires. A layer of insulation always covers the copper wires that conduct electricity. This insulating layer is usually made of plastic, but it also be made of rubber or even of cloth. These coverings keep electrical energy from moving where it shouldn't when it flows to other conductors. Insulation also makes these electric cords safe to the touch. That's how we're able to pick them up and move them, and plug them into an appliance when they're already plugged into the wall without getting shocked. Heat also moves slowly through air and other gases. That is because the particles in these gases are far apart. Energy does not move easily from one particle to another. You might think that this isn't useful, but in fact, that property is very useful in our homes. Many good insulators are filled with little pockets of air. For example, the walls and ceilings of many homes are filled with fiberglass insulation. You might not know what that is, but if you see on the screen here, this pink stuff, this is that fiberglass insulation. This insulation is made up of tiny pieces of glass. The fibers form a tangled mat with many air spaces or little air pockets. This insulation allows your home to stay a different temperature than it is outside, both cooler than it is outside in the summer and warmer than it is outside in the winter. Winter coats are also good insulators. This is important when you want to go outside in the middle of winter. They prevent heat from being conducted away from our body. Many winter coats are made from fluffy materials like wool or even feathers. Down clothing, that means it has tiny little feathers in it, is a very good insulator because it has a layer of small goose feathers. Heat does not move easily through the feathers, keeping us much warmer than if we didn't have that coat on. Now, let's talk a little bit about what we call it when that electric current moves. We can see on the screen that we call this an electric circuit. That is the pathway through which electric current flows, the path that the current follows as it moves from one place to another. Now we need a few specific things in order for the electric current to flow easily, or maybe even to flow at all. You can see in the picture, we have a battery. That's going to be the source of our electric current in this situation. We always have to have some kind of source. And then we need something for the current to flow through. It's going to flow through the wires. In the picture, the wires are red. And it's going to flow to the light bulb, which is set in a little light socket here. So we need an energy source. We need the wires for the electric current to move to. And then we're going to need something to show that the current is actually flowing. We have two different types of circuits that we're going to talk about today. A closed circuit. A closed circuit is a pathway that allows an electric current to flow freely. Basically, if the electric current is closed, that means there are no gaps in the wires throughout the circuit. we can see that the battery connects by a wire to this, which we're going to call a switch. The switch is closed, meaning the current will flow in one side of the switch, through the switch itself, and back out the other side, through the next wire, onto the light bulb, through the socket itself, into the light bulb, and then back out, and back to the battery. This circuit creates kind of like a circle and is closed. Now what happens if the switch was opened? We don't have a switch in this picture, but we could imagine a switch up here at the top that is open instead of shut. In this case, we would have an open circuit. That is a pathway that prevents electric current from freely flowing or stops the flow in some way. In the previous slide, we saw that the electricity must be able to flow in a complete circle to complete the circuit. Here, we have a wire that is not attached to anything. It flows to the light bulb, but it has no energy coming into it. The tiny wire here is not connected to the wire flowing into the light bulb. Therefore, the circuit is open and will not light the light bulb in this case. So today, our experiment or our investigation is to try to create a closed circuit and light up a light bulb. You could certainly try this at home, but you would need a few tools and probably some supervision from your parents in order to do so. Let's take a look at the tools that we would need in order to complete this investigation. The first thing you would need is the battery. We've got a D-cell battery here. You would need your wire. This wire is actually from an old extension cord that I've just cut apart. You will need some scissors. You will need some wire cutters, some tape. We've got some yellow electrical tape here. And finally, of course, we'll need some sort of light bulb. I picked this light bulb because it has the two prongs here that would plug into the light socket. They're going to be more easy for me to connect to the wire itself. So let's take a look at what we would do. The first thing you need to do here is to cut off two small sections of the wire. They don't need to be very long, but long enough that we can connect the battery to the light bulb easily. So there's one section of wire, and here is a second section of wire. What you're going to do is cut just through the plastic part. You don't want to cut all the way through because you need the metal wires inside. You're going to cut through that plastic part very carefully, and then hopefully, let me get a pair of pliers here. You might need some pliers as well. See if we can pull this off when it comes. Good. So now you can see the exposed wires, and it's not connected to anything on the other end. It's not plugged into the wall, so it's safe to touch those exposed wires. And I actually like to twist them just to make them a little bit more compact. And you're going to do the same thing to the other side, and eventually your wire will look like this. The next thing you're going to do is repeat that step with the other wire, so you'll have two that look like this. After that, it's time for your battery. Just going to lay my battery here so it doesn't roll away. I have my wire. I need a small piece of electrical tape. Because I need to make sure that my wire does not come off of my battery. So cutting my small piece of electrical tape, and I'm going to tape the wire to the battery itself, making sure that it is attached firmly. Then you will do the same thing with the other wire and attach it to the other side of the battery with the tape. Once you have done that, then you are ready to try to attach your light bulb to the rest of your circuit. Now, as I did this experiment earlier, I found that one battery was not enough to light this light bulb. As we've talked in class, sometimes an experiment doesn't go the way we want it to or the way we thought it would the first time. And so, after further investigation and further experimenting, I realized that the best way to make this light bulb light up was to have 4 batteries connected. These 4 batteries give us enough electrical energy to hopefully light the light bulb. Now, I did also find that if you can see here, it was best to twist the wires around a little bit so that it kind of curls around the light bulb like that. And so we're going to give it a go. Let's see what happens. Got my first prong connected, maybe. Make sure it fits in there okay. So I've got the first prong connected, goes to the batteries. The batteries are all connected to each other. I have them taped together so that they won't move. And then my goal, or what I'm going to do, is just touch the other wire to the other prong of the light bulb. And let's see what happens. So you can see that the light bulb is lighting up. Now let's try this. Let's go ahead and turn off the light of the document camera. We'll see it more easily now. Here we go. So if, let's say, the power ever went out in your house and you realize you don't have any candles and your phone is dead, all you need are a few batteries, some wire, some tape, and a light bulb. And you can find another way to light your house. So that is all for today. Hope that we enjoyed our little experiment with the light bulb. Again, that is something that you could easily do at your house if you happen to have those supplies. Take a quick look, see what you can find, see what you come up with, and if you're able to, take a picture of your circuit and post it on the Google Classroom for your teacher to see. That'll be a great thing to do this weekend, especially today on your day off. So I hope that everyone has an awesome weekend, and I will see you next Friday.